Well, dear my students, here in this video, the heading is half power frequency, bandwidth, and Q factor. This topic is also important to know so many things which we are dealing in life, like communication and other things. But sometimes teachers teach in the class, sometimes they do not. We know that when an AC source is connected across series LCR circuit, then electrical vibrations start in the circuit. I told you many times that when alternating current flows in circuit, then only electrons oscillate about their mean position. I mean to say this thing here. The power delivered to the circuit by the source, by AC source, of voltage average power, I must say here average power delivered to circuit by cells in a complete cycle. Average over the complete cycle is P bar equal to V0 I0 upon 2 cos phi. I have proved it in last video. Power dissipated given to a circuit, delivered average power, which may be dissipated in the form of heat and light and other electromagnetic radiation. Now we know I0 is equal to V0 by Z, and cos phi also R by Z. You remember cos phi here is called power factor. So P bar, average power delivered to circuit, is given by V0 square into R upon 2Z square. 2 times Z is there, and Z square is also equal to R square plus omega L minus 1 upon omega C whole square. What is omega? The frequency of source, angular frequency of a source, which we have applied. And I told you that if the frequency of source does not match with the frequency natural diffusion of LC oscillation, then electrons pick up the frequency of source. So electron will be oscillating with this frequency omega. Now here we see if omega tends to 0 or omega tends to infinity, If omega is 0, this term becomes infinity, so power tends to 0. And similarly, if omega infinity, this term will be infinity, a 0, again power 0. Then every power p bar tends to 0. Very small. Now, however, if omega equal to omega r, resonant frequency, dear student, I told if we have LC circuit, then omega equal to under root LC. यानी कि frequency of oscillation of electron depend on value of LMC also. But here we have a circuit here, inductor, capacitor, resistor, and here the source. So in this expression, omega frequency of source, and omega is also here frequency of electron which depend on LMC. If this frequency does not match with source frequency, then electron oscillates with the frequency of source, and that is a case of force vibration. It is very important to understand. Then average power. I am telling you how. If omega tends to 0 means बहुत छोटी हो, omega tends to omega बहुत बड़ी हो. It is very large, it is very small, then power tends to 0, power will be very small. If however omega equal to omega, source frequency match with the natural frequency, then average power dissipated or delivered to circuit. Delivered to circuit is maximum. That is P bar maximum will be V0 square, V0 square upon 2R. V0 square upon 2R. So from here V0 square equal to P bar maximum. Bar means average into 2R. Putting this value of V0 here, what do we get? Putting this value of V0 square, we get P instantaneous power. Average power. P maximum, P bar maximum into 2R square upon twice R square plus omega L minus 1 upon omega C 4 square. To cancel, so this P bar comes to here. P maximum upon into R square plus omega L minus 1 upon omega C into R. So if omega is equal to omega R, then from here we get ये 0 हो जाएगा, then P equal to P maximum. तो यानी के average power dissipated vary with frequency. This equation shows that this average power delivered to circuit in one complete cycle vary with frequency omega. If omega is equal to omega, P bar equal to maximum. But if omega are less than omega, it decreases, and if omega greater than omega, again it decreases. And we can plot a graph here between if we plot a graph between omega, or you can take frequency, and here P bar. It is P bar maximum. At omega equal to omega, it will maximum, and then the graph is obtained like this. If you plot graph between omega and P bar, we get this graph like this. It is maximum at omega equal to omega r, and then falls or decreases very sharply as frequency is lower than omega r or increase omega more than omega r. Now there we can take 2 points here at which point A and B are on this curve. Corresponding to these points, power delivered is P maximum by 2. And these points are called half power points on the graph, and frequency corresponding to this. These points are called half power frequencies, omega 1, omega 2. Dear friend, please listen me carefully. I am telling you very important thing which you can apply to understand communication purpose. How do we communicate, and how do we tune our circuit, or how do we tune our television or radio or telephone to a particular channel. That's why I am telling you. So P, these frequencies omega 1, omega 2 are called. So graph shows the variation of P bar with omega. The power is maximum. P bar is maximum at omega equal to omega r. Here omega r is called resonant frequency, and you know at resonant frequency impedance minimum equal to r, current maximum, power factor is 1, phase difference, current voltage 0. In this graph, A and B are 2 points corresponding to P maximum by 2. P bar maximum by 2. The frequencies corresponding to points A and B are called half power frequencies. And the difference omega 2 minus omega 1 is called bandwidth. Here is the problem. What is bandwidth? Well, the difference of highest and lowest frequency of half power frequency is called bandwidth. But why do we are studying this topic? In our communication, radio communication or television communication or any data transfer, we need electromagnetic wave. है ना, electromagnetic wave travel with the speed of light. Any signal, my own voice has not a single frequency. In music system, there is a big number of frequencies, singer sound, harmonium sound, tabla sound, all have different frequencies. And remember, dear student, a single source of sound produce along with a central frequency, some higher and lower frequencies. So a signal, loud sound signal or any other signal is superimposed over a carrier frequency. A carrier frequency होती है, which is electromagnetic wave, which is a high frequency. Any signal is superimposed over this carrier frequency. Carrier frequency. Actually, this topic has been deleted from the syllabus. That's why there is problem. And our signal is superimposed, which have, this is supposed carrier frequency. Around this, some low frequency, high frequency will be possessed by the signal, and those vary within this range. Every signal, every channel has its own carrier frequency. So if we want to tune our TV or radio with that particular channel, then we have to bring to this frequency our circuit. In our radio circuit, there is another RC circuit, which frequency can be changed by changing L or C. I told you. But if the graph is flat, suppose graph comes like this, frequency and power. So for all these, the current is power is maximum. And in this range, there may be many channels. To avoid that overlapping of sound of different channels, this peak should be sharp. And peak will be sharp if omega 2 minus omega 1 is small. So that we can get only one signal. I think you are getting my point. Any signal has a group of frequencies within central frequency, which is our carrier frequency. Single signal is not a single frequency. It has a number of frequencies within this range, omega 2 minus omega 1, around this symmetrically. So to have a good tuning, this peak should be sharp. Resonance जिसको हम कहते हैं, resonance should be sharp. है भाई? Resonance should be sharp, and it will be sharp only if this width is small. I hope, and all these frequencies are important. Our audible sound frequency varies from 20 Hz to 20 kilohertz. So in this range, all frequencies are there. So please try to understand what I am telling you. Now in next video, I will take calculation of bandwidth in terms of resistance and inductance. By frequency जो हमारी ओमेगा है, it is 1/√LC. तो difference of these widths depend on R also. क्योंकि larger the R, flatter will the graph. मैंने बताया था अगर हम ओमेगा और पावर ग्राफ बनाएंगे या करंट ग्राफ बनाएंगे So it will be flat if R is large. If R is small, it may like this. So how does the difference of frequency depend on R and R? I will take in next video, because that also requires a lot of mathematics. So please watch this continuously. The next video also is very important.